Okay, the next topic is glycerol reacts with oxalic acid. What's the formula for oxalic acid? It's one of the weakest acid present in tomato. Yes, formula for oxalic acid is COOH twice. COOH, COOH. Now glycerol reacts with carboxylic acid to become one of the, you will see now, glycerol CH2OH bond CHOH bond CH2OH reacts with formic acid. So you can write like this COOH and COOH. See here, removal of water. So what is the remaining? CH2O O C COOH and CHOH here CH2OH. Okay. Here again decarboxylation reaction takes place. Decarboxylation reaction means removal of CO2. So minus CO2, this H will add here to become acid. So CH2 COOH here, CHOH here, CH2OH. Initially you are going to add oxalic acid at 383 Kelvin. How much Kelvin? 383 Kelvin. That time you will get monoxalate. You will get monoxalate followed by decarboxylation reaction. Now removal of CO2. Now you got glycerol monoformate OCOH. Can I write this out? CH2 OCOH OCOH glycerol monoformate. Glycerol monoformate is the end product. Now glycerol monoformate undergoes hydrolysis reaction. Hydrolysis reaction means, okay, right, here is H, that side is OH. So that hydrolysis reaction means HOH will come. So we will get glycerol. Glycerol means CH2OH bond CHOH bond CH2OH. What is remaining? See here, HCOOH. HCOOH, formic acid. So glycerol converting into formic acid. Glycerol to formic acid. Clear? Glycerol reacts with oxalic acid to form a glycerol monoxalate. After that, decarboxylation reaction takes place to form a glycerol monoformate. After that, hydrolysis reaction takes place to form a glycerol and formic acid is the product. Glycerol and formic acid. And one more thing, glycerol reacts with oxalic acid to form one unstable compound, but this reaction takes place at 533 Kelvin. Here, glycerol, so CH2OH, CHOH, CH2OH, oxalic acid means COOH bond COOH, followed by removal of water molecule. What is the remaining? 533 Kelvin, CH2O C CHOOC. Here is CH2OH. That is a unstable compound. Okay, that is the unstable compound. So what will happen? Followed by decarboxylation reaction takes place to form allyl alcohol. Decarboxylation means minus CO2. CO2, CO2. What is remaining? Become a CH2 double bond CH bond CH2OH, namely allyl alcohol. Okay. So glycerol reacts with oxalic acid at 533 Kelvin. Removal of two water molecules. Remaining acid is unstable compound. So the remaining decarboxylation reaction takes place. So removal of two CO2, remaining allyl alcohol. So how to prepare allyl alcohol from glycerol? Or how to convert glycerol to allyl alcohol using oxalic acid? Glycerol converted into allyl alcohol. Very important question. Then oxidation reaction. Oxidation reaction, glycerol undergoes oxidation reaction using so many oxidation agents like pentan reagent is one of very important reagent. You know what is pentan reagent? That is very important one mark question, namely combination of ferrous sulfate and hydrogen peroxide. Pentan reagent. Pentan's reagent mean what? Combination of ferrous sulfate and hydrogen peroxide. Okay. Combination Fe2 plus ferrous sulfate and hydrogen peroxide nothing but Penton's reagent. Okay, not only this one, with dilute nitric acid, it forms glyceric acid is formed, and bismuth nitrate, it gives glycerol to mesoxalic acid is formed. In C pentan reagent, you get glycerose, using glycerose, because you know very well primary alcoholic group converted into, that means primary alcohol oxidase to aldehyde, aldehyde further undergoes oxidation carboxylic acid product. Secondary alcohol undergoes oxidation reaction, ketone is the product, ketone further undergoes oxidation reaction, carboxylic acid is the product. Using this concept only, we are going to discuss the next oxidation reaction. Oxidation reaction of one, glycerol. Okay, initially glycerol. What is the formula? CH2OH, CHOH, CH2OH is a glycerol. Okay. Now oxidation reaction. Oxidation reaction. You know very well, primary alcohol undergoes oxidation reaction. Aldehyde is the product. So primary alcohol converted into aldehyde because removal of two hydrogen atom. So CH2O remaining as it is. What is one more way? Secondary alcohol. This converted into ketone. So as it is remaining. CH2OH, CO, CH2OH as it is. Clear? Now this one is undergoes oxidation reaction, so that you know very well aldehyde group converted into carboxylic acid group, so that COOH, CHOH, CH2OH. Okay, how this convert into carboxylic acid? Very same thing. This primary alcohol also convert into carboxylic acid, so that COOH, CHOH, here is COOH. Now both are converted into carboxylic acid groups. Okay, now this one undergoes oxidation reaction. This primary alcohol converted into, what will happen? Primary alcohol to carboxylic acid. This primary alcohol to carboxylic acid. So that COOH, COOH. Okay, followed by oxidation reaction. Oxidation reaction mean what? Removal of CO2, remaining COOH. COOH is the product. COOH and COOH is the product. That means oxalic acid. That means oxalic acid. This one undergoes oxidation reaction also. This is the product, because COOH is second alcoholic group oxidized to ketone. Finally, oxalic acid is the product. Now, oxalic acid again undergoes oxidation reaction. What will happen? H2O, 2 CO2 molecules. 2 CO2 plus H2O. Okay, basically, only one point you have to keep it in mind. Primary alcohol undergoes oxidation reaction. Aldehyde is the product. Aldehyde further undergoes oxidation reaction. Carboxylic acid is the product. Secondary alcohol undergoes oxidation reaction. Ketone. Ketone become a carboxylic acid. It's a very basic concept. So that both the primary alcohols convert into carboxylic acid. First, initially primary alcohol converted into aldehyde, then aldehyde become acid. Very same way, this primary alcohol also converted into carboxylic acid. This is secondary alcohol, so that become a ketone. Again, these two primary alcohol become a carboxylic acid. Removal of CO2, oxalic acid, oxidation reaction, removal of water plus 2 CO2 molecule. It's nothing but oxidation reaction of glycol. What are the uses? Manufacture of explosives like CNG, sand bridge in automobile radiators, sweetening agent and beverages, so moisturizing cream and other cosmetics, copying ink, stamp padding. These are the uses of glycerol. Okay, thank you, students.